it's so easy to go to a security conference or be involved in security, and it's all bad news and difficulty and communication challenges and cultural challenges and development challenges and financial challenges and fear and news and politics. It's like it's a lot of bad news. It's a lot of bad news. And I try to spread a little good news. My name is Jim Manico. I'm primarily a secure coding instructor. I teach people how to write secure code. So I'm trying to point out the good things that I see in frameworks and languages that really make me believe that there's hope for this industry. There's hope for secure software as we continue the path of software development in our industry. Look, we put people on the moon. We've done, as a race of beings, we've done so many amazing engineering challenges successfully. I just see secure coding as another intellectual challenge, engineering challenge that can be solved through proper discipline and engineering techniques. When I look around at all the frameworks that we use to build software, I see so many little things done incredibly right that in the future, if we start putting all these things together, we're going to be able to provide a secure coding framework or just a software development framework to developers that have huge classes of problems that we struggle with today fixed automatically for the developer. So let's start with a quick and dirty framework control maturity model. When we look at Spring or Struts or Ruby on Rails or Go or Node, whatever your framework is of choice, we want to look at the needed controls to build secure software and measure how good the framework is doing at putting that control into the framework. So this is my quick and dirty maturity model when we analyze a control and look at it within a framework, right? So the first one's going to be, of course, we don't defend against it in any way in our framework, right? That's just straight up no, don't do that. There is a lot of ways to integrate controls into a framework. If you're not even considering it, you're way off the match, at least for that particular, you're way off the mark for that particular control. And I think especially if you're building a new framework today, whether it's a generic one in open source, whether it's a custom one for your company, and you have this greenfield chance to build a new software framework, and you're not adding core controls in, that's a huge lost opportunity, and I dare say critical mistake. How about number two? We have the security control API available. Like if you're a Force developer for Salesforce, they have output and coding libraries, all this stuff available to you. So it's available, but it might be a bit challenging to use. It's not documented or it's incredibly complex. That's also a big no, right? I mean, we want something that's not going to require a lot of additional labor from the developer. How about this? What about a simple to use API that's straightforward with really good documentation? I still say no, because a developer has to take action and change configuration, and these benefits still requires a developer's interaction. How about this? How about an automatic defense? It's there. You turn it on and it's there, but it's off by default. You have to go in and enable configuration to turn that control on. That's also complete no. What we want are a series of automatic defenses that are on by default and at least block that activity from happening. We want an automatic defense that may fix bad code dynamically through recursion and similar, or we want an automatic control that just gives us an additional good defensive property in our framework. So when we look at, we're going to go through and look at a couple modern controls and frameworks in this presentation. We really want to see them hit 5, 6, and 7, preferably 7, where we're just adding a good solid defense into our framework, and the developer gets that benefit just by using the framework, not by having to enable it or use it or call the right API or sacrifice a goat, whatever, to get it right. Automatic defenses are where it's at. That's what we're going to focus on in this presentation, automatic defenses. And do you think it's possible? Do you think it's possible to build a framework with certain controls and defensive layers built into it that developers get automatically without having to take any action? Do you think this is realistic, or is this more of a pie-in-the-sky idea? What do you think?
Realistic.
It's realistic, especially for more generic technical controls. It's not just realistic. I say it's a major gap if you're not doing it. Can you think of some areas where adding automatic defenses into your framework is not possible or not realistic? Like I'm gonna say like the injection class of problems, much of what we'll be focusing on, I think all of them are solvable through automatic defensive strategies. Can you think of any areas where it's not gonna be, we're not gonna be able to pull this off?
Where you need to parse HTML and stuff like that.
I'm gonna show you that. In fact, a talk from like less than 12 hours ago that talked about automatic methods. So I think even that, a really hard problem, I was convinced in the last 12 hours that it is possible. I'll show you some of that research. So I dare say that's true. Anywhere else you think it's not possible to automatically secure it? Large legacy code bases. I'm gonna, for certain risks maybe, but I'm gonna show you a couple hacks into PHP and proposals that will take legacy existing SQL injectable vulnerable PHP code bases. There's a lot of that out there, and add automatic security to it without needing to involve the developer in code. So let's see if you buy it or not. We'll look at it. Where else do you think is really not possible? And the questions were, can we, I'm sorry, just for the recording, can we automate, he was like, we can't automate HTML sanitization from a WYSIWYG editor. I agreed with you until recently. I think there's other solutions there. We'll look at them. The other question was, or comment was, we can't automatically secure an old legacy code base. And I tend to agree with that, but there are some methods to consider at least. There's something else I'm looking for though. What security areas or security defensive topics is it really tough to just automatically provide security at the framework level? What's that? Commercial off-the-shelf software. I'm looking for more, not the kind of software, but more of the architectural security component in that software. Like here's one subject, cross-site scripting defense. Another topic is password storage. Another topic is authentication best practices or injection protection. What security area do you think we're always gonna have to write ourselves in some way?
Authorization, authentication.
Bingo, that's exactly what I was looking for. There's a lot of companies who are like, well, we could just buy our product and slap it in front of the app and you got really good authentication. Or buy our enterprise product, just slap it on your app, and now you got really advanced multi-tenant access control. And they don't exist. In fact, in our frameworks today, I conject that almost no one has access control correct for the modern era. When in the modern era, we need to support two major access control features. Multi-tenancy, multiple customers in the same code base with different rule sets, and data contextual access control, row-level access control. This comes up all the time now. It's no longer a special case. It's a normal case, and all of our frameworks don't even begin to address that. So we are forced to code that stuff ourselves. Authentication, man, that's a gelatinous mix of OAuth, OpenIDC Connect, SAML, your normal single sign-on layer, your normal web app level authentication. It is a huge morass of technologies that we have to stitch together. It is really hard to buy your way or framework your way out of those things. So I agree. Where does that leave us? Let's talk about, again, these should be common defensive strategies and common risks that we've talked about multiple times. So let's start with, I love this topic, cross-site scripting. Let's talk about automated cross-site scripting defense and look at some of the strategies out there, right? I like to look at Rails. Rails is one of the early popular frameworks that integrated automatic defense. So in Rails 3 or 4, when you just drop a parameter in a Rails user interface without needing to configure anything, without needing to involve the developer, without needing to enable some API, when you drop data in a UI, Rails escapes, as we see in the first example there. And then if the developer wants to turn off escaping, like to render HTML to that variable, then they can send a raw parameter, or so say this, say parameter .html safe. When you specify a variable is safe, that means you're going to turn off security and let the content render directly. When you as an auditor look at this call, HTML safe, what does it say to you? As an auditor, really, what does it say to you? This is a safe function. It says the opposite of what it should. So this is an early example of a framework providing automatic security with a way to disable it. I believe it was designed fundamentally wrong, because when we audit code, HTML safe does not make content safe. So they're an early adopter of auto escaping. Let's look at it done a bit better. if we look at most of us who are building new development today, you're either using React, Ember, or Ajax, or you're a couple years behind, I state with respect. You're using one of these three major JavaScript frameworks to do advanced user interface development. And again, when you drop data into React, especially with their JSX technology, a core technology, it automatically escapes. And if you're not using JSX with React, you're probably a little bit crazy, because this is a core component that provides a lot of automatic defense. It escapes everything by default in some of the main contexts. The problem is, why I'm critiquing this, is because React doesn't fully protect you from XSS. There's a bunch of vectors when this really well thought out framework built from Facebook, they punted on a few edge cases within React they could have locked down with a little bit of design work, but they didn't. So although I'm a big fan of the work they're doing here, I feel it's a little bit of a missed opportunity, because they do great things like this. All strings are converted to HTML entities and tokenized. It becomes extraordinarily difficult, in some cases impossible, to XSS through a standard Ruby on Rails template. Through a standard React JS program through normal programming. However, we have these kinds of problems where auto escaping just doesn't save you all the time. If you're putting untrusted data into an event handler, on click, on blur, even escaped data executes in an event handler attribute. So we have that problem that comes up often. We have issues where if you're accepting a URL from a user and you drop it in an href, they're going to encode it so you can't break out of the href, but they still support JavaScript URLs. A problem we had in blogging software a couple years back pops up again, even in brand new frameworks. We also have, but what they do right, what I do like about React is framework developers are getting a lot more intelligent about how to turn off security. So when you want to turn off automatic escaping in React, you have to say, dangerously set inner HTML. Yes, that's the first time I've seen a framework that gets the name right. And it really, without having to document, without having to educate the developer, just by naming and building the framework correctly, the developer gets it instantly. That's a big win. And the problem is, though, when things do go wrong, like you have a problem with the auto escaping technology where untrusted data drives the kind of data, and the server side looks at that variable to determine, is this a JSON object? Is this a string? And the client can drive that. Now the attacker can turn off escaping just by manipulating input. And we saw this against React in version 0.14. They eventually added an automatic mechanism where server-side code would now recognize input properly and handle it properly. So now, boom, they had to go through a couple bumps, but again, there's a few edge cases I can still pop React by using it normally and insanely. That's a problem. Not everything is properly escaped. When they turn off escaping, they make it correct. So it's okay. They're not fully up to maturity stack level, but they're reasonable and made a lot of smart choices overall. Even better, and I'm going to say one of the best cases of a framework handling cross-site scripting by far is Go templates. No one's even close to them right now. Go is one of the only user interface template technologies. Don't walk around, Jim. I'm sorry, I forgot about that. Stay put. Stay put, okay. Yeah, one of the things that Go templates does well, first of all, it's a very concise code base. Google rewrote their whole file upload mechanism in Go and went from several million lines of code to a couple thousand. It's a very concise, expressive language. I really like the combination of the two. They are contextually escaping in the right context automatically just by using the template. And if you render a variable in a location that can't be escaped safely, the template will not compile and it won't work. So, and even better, this is mind-boggling that someone's doing this in the last couple of years. Look at this context right here. Look at this context. It's a query string parameter inside of an href tag. Before you look here, how am I supposed to encode this? If I'm in a URL and I have a variable, I'm dropping it in a query string parameter, how am I supposed to encode this for XSS defense? Say it quick. What else? What's that? Which one? URL encoding or HTML encoding? Which one? URL. The answer is both. I mean, you can get away with URL encoding and not get popped, but what you're really supposed to do is first you URL encode certain characters because you're putting it in a URL context, and then you encode it with HTML encoding because you're in an attribute. Most developers don't get this right, but here's a framework that's doing this right. It's encoding both URL encoded tag, and then it's HTML entity encoding the single quote so it's properly represented in output. It's mind-boggling to me that from what we see from Google, an example of this done right. My hope in the future is that every single software framework will be doing this in just a matter of a couple years. Otherwise, I don't think there's a lot of hope for this particular risk category. So it can be done. What's an equally good example of a framework that handles cross-site scripting automatically? Any thoughts?
MVC.
From .NET?
Yeah.
It's missing a lot of, I'll mention it briefly. It's missing HTML sanitization, a key part of XSS defense. It has the anti-XSS library from .NET, but the thing is, I don't just use MVC and get the protection. I have to be a smart developer and use the APIs call correctly, and that's lower down the maturity stack. And .NET's one of the first ones to have an output encoding library. They were the first to give us the ability to write secure user interfaces, but they never carried it far enough. Anyone else want to jump in? What software development framework has one of the most mature cross-site scripting defenses in it in 2016? I'll give you a hint. It's not linear. It's Angular. Anyone have any experience with Angular around cross-site scripting defense? Anybody ever tried to pen test through an Angular app before? Is anybody here in the room with me? No. All right. It's still early for this, right? So we have Angular that has two different tiers of automatic HTML sanitization. When you try to bind a variable of here's the snippet at the top. It's an attack. When someone mouse overs it, the attack launches. So here we have ng bind. Let's do this one first, automatic escaping. When we use the basic ng bind in Angular, that's how you put data on screen. There's nothing special about this. It automatically contextually escapes in most contexts, so I see the code, but nothing executes. Now look at this. This is awesomeness. If you say, are you ready? Deliberately trust dangerous snippet. If a developer does that and lets untrusted data go in there, that's just Darwin at play. That's developer Darwinism. And we see it actually execute here, and they turned off good security for no reason. I can't help you there. But at least as an auditor, I can audit this stuff very quickly and see all the places where escaping's turned off and deal with it. But again, most variables automatically escape, and if you declare the widget to be HTML, it allows a whitelist of certain markup to go through and strips everything else out automatically without configuration. Just if the average new developer uses Angular even modestly correct, the major class of XSS goes away. Now here's the problem. Where does your app go wrong? If you look at the top XSSers on the planet, in my opinion, number one XSS guru is Mario Heinrich from Germany, a member of our community. Number two is Ashar Javed from Pakistan. He's hit every bug bounty known to man. Chris Christoph over at Google. These are some of the top XSSers on the planet. And when you give them Angular, there's a couple edge cases they can pop through. It's problems in the framework that are super esoteric. These guys don't always like to give their secrets away. Mario doesn't like to give his secrets away. That's all right, it's his prerogative. So he has a couple of evasions he doesn't want to share sometimes, so the elites can get through. How do you stop Mario from XSSing even a fully locked down app? And he can. How do you stop the elite attackers from popping your app? You got to add one more technology to the play here. Nope. WAF are for wimps. Don't even go there. WAF ends with an F for a reason, because that's what you are if you depend on it. Sorry about that. Bang, who said that? That's the only technology available today that will stop the deep attackers from popping your app. And Angular is one of the only frameworks out there that natively allows for a CSF plugin with proper configuration. They change different CSS code. It hurts performance a tiny bit, but it's got the complete trifecta of defenses: automatic escaping, HTML sanitization, content security policy integration, and when you turn this stuff off, the API is abundantly clear. This is the future of XSS defense. So, and as a bonus, we see some of the Googlers and the W3C folks working on a technology called SafeNode, which will do some of this work on the client as well at the W3C. And that was like a couple days ago this conversation was going down. Another interesting thing about Angular is that as a user interface UI framework, the primary use case for Angular, they have really good cross-site request forgery defense built in for the modern era. Many Angular apps, they're not traditional web apps. What do most Angular apps talk to on the back end today? What do most heavy JavaScript built applications, how do they talk to the back end? It's all about REST now, correct? And this is a very profane thing. I want to steal yourself when I say this. You're not going to believe this. I know it's crazy, but REST developers want to build something called a stateless REST microservice. Have you heard that? This hurts me to even talk about this. Statelessness? What do I mean by I want my server, my heavy transaction e-commerce with lots of access control, but I want it to be stateless? What does that mean? What the company is saying is this. They're saying this. It's like, look, we only have a limited amount of resources. We have executives, and they have got to get their bonuses. You know how much a Ferrari costs to get fixed? So we're not going to bother actually buying real hardware for the servers. We're not going to bother getting a real pipe in. We're going to be super cheap, get you low bandwidth to your server, and get you the cheapest server that I can give you without complaining. Remember, Ferraris and bonuses, just the way it is. And so how can you use that server with as little resources possible and still scale the whole world? That's where stateless web services come in. Instead of having to store this on the server and take that hit both in performance and storage and all these, we'll just take a cookie, pack the session in a cookie, do some crypto hand waving, we'll sign it, and and then we'll send it down to you, and we'll do nothing on the server to hold state. It's that cookie in your browser that holds state. And good luck with that. How does that sound for development? I think it's insanity. But the reality is what we're doing. And so as an amateur security professional, I can say, don't do that. That's amateur stuff though, right? As a professional, I'm going to say, all right, so you want to do some really crazy stuff? All right, cool. Let me help you do that as secure as we can. So when you're doing restful, stateless services, how do you do cross-site request forgery defense? What's the main defense to stop cross-site request forgery, first of all? What's the main defensive pattern? A cryptographic token. Where do you normally keep that token? In the server, in the session. So what do you do if there's no session? How do you track that nonce or that state? You do. No, you do. You just don't put it in the server anymore. You pack it in the cookie. And so we have no client-server comms. Each request must be independent and with the information to complete that process. And the session state is now on the client. And to do this right, at the very least, you're doing a digital signature on the cookie. Why at the very least do we sign the cookie? And a stateless cookie contains usually the login time, the user ID, and hopefully not that much more. Why am I saying we have to sign this cookie at the very least and verify it on the server? What benefit do I get from that? Non-tampering. If I give someone a session cookie and that is their state and they can tamper with it, what might they tamper? How about that user ID? Boom, game over, right? So Angular has a default cross-site request forgery pattern in it called the double submit cookie defense. This defensive pattern was discussed for the first time probably 8 years ago by a certain gentleman who's in the room right now, actually. And we saw a lot of frameworks begin to use it years ago, but just in the last year or two, since we were moving so quickly to JavaScript, most of those frameworks provide this exact defense to make your JavaScript UIs double submit cookie, stateless REST, cross-site request forgery, defense ready out of the box. And all you have to do is check for a few variables on the server. All you're doing is you're checking to make sure a cookie called XSRF token is delivered to the browser, and it also has a header with that same value. So you're just checking to make sure they match without having to track any server state. Why does this defense work? It's an older defense, but it's something that's in newer frameworks that need to be in newer frameworks since this pattern's become so common. The reason this works is because you're usually, for your cross-site request forgery cookie, you're usually setting a cookie that is not HTTP only. When you flag a cookie as HTTP only, what tangible benefit do you get? More tangible, not philosophical. What can no longer read your cookie? JavaScript. Now, for the double cookie submit pattern to work, you need JavaScript to read your NOTs cookie. So you turn off HTTP only, and when someone hits submit on your server, you need JavaScript code to read the value out of the cookie, put it in the request header, and ship those both up. The reason this works is because cross domains hosting your cross-site request forgery attack, how much can they read your cookies? They can't. So if the origin of the page is a different site, that means an attacker is hosting a cross-site request forgery attack, then that JavaScript can't read the cookie, and there's no easy way for the attacker to ship up both the cookie and the header with the value. And this is why this defense works. It depends upon origin policy for this to be successful. Again, bad domain can't read the cookie, and the good guy server is just checking to make sure both of these values are the same. And again, we see this integrated naturally into Angular without any action on the user, developer needed to be taken. And this is one of the better ways to solve this problem. Emerging defenses I see people talking about in this category is the era of the NOTs is going away in most modern applications. I haven't seen anyone build this yet. I've just seen it in some applications. So and if you look at this up the maturity stack, it's still not at the top because the developer has to write the processing code on the server to check double submit. Even better is, I think we see people who are going away from NOTs and just checking the origin and refer header to make sure the landing origin of that page was the same domain. And I try to not depend upon origin policy for the security, but we now have origin header being sent reliably in most browsers. Firefox is about to play ball. I get a sneaking suspicion the Safari team may care about this soon as they bring in smart people, right? And so we have the next generation is going to be origin refer header checking to make sure the landing page is the right domain. We'll look at a couple other emerging defenses in just a moment. Another key thing, and still to this day, when you look at cross-site request forgery, one XSS flaw and your cross-site request forgery defense is gone. What do you think is more difficult for your app? To get a cross-site request forgery token working, or to get your app to be 100% bulletproof from cross-site scripting? What's more difficult?
Cross-site script.
By many factors. I even think cross-site scripting defense in a legacy app is more difficult than getting crypto right. And it's so many places things can go wrong, so it's a big challenge. One XSS flaw, and I can just read the token from the page and replay it. Stored cross-site is a stored CSRF or just a stored XSS. Because if you get XSS from a different domain, it becomes easy to violate double cookie submit. So I think the next generation of this defensive strategy will be origin header checking. Next, let's look at Angular and just real quick. This is an older attack, but we even see new frameworks putting this in the last year or so. If you have a pure JSON object, then cross domains can read that data in a very obscure way. It's called JSON hijacking. So most modern frameworks will pad your JSON with a couple characters, and now it's not proper JSON. It stops this hijacking attack, and then your client-side code will grab the first 4 characters from a JSON, first 5 characters from a JSON response, discard it, and then parse the rest. And this is really well thought out. It's built into Angular by default. And now my hope, as a side note, my hope for a better, a little out of strategy, out of order here, but who cares? Emerging CSRF defenses, I think this problem will help this problem completely go away. The main one from Mike West is same site cookie attribute. And look, this is an active discussion from a couple days ago. So this is now really on the bleeding edge of what standard bodies and next generation frameworks are trying to do to stop cross-site request forgery. When you set cookie here, like this, it doesn't matter what the origin of your page is. It doesn't matter what page initiated the request. That cookie leaves the building. This is how, again, cross-site request forgery works. I host the attack on an evil website. The victim hits that page and the request goes off. And who cares where the request originated from? That cookie is going with it, unless you flag it as same site. It's active in Chrome today. A same site request says, unless the origin and the page I'm going to are the same, don't ship the cookie. Because usually you're hosting a CSRF attack on evil.com that makes a request to good.com. Oh yeah, because Mike West is one of the lead developers of Chrome. He's also a member of the W3C, and just on January 20th, he did a little modification of the specification. It's available for testing, I believe, in Canary. A quick check and we can answer that. But this is bleeding edge, and when same site cookies are in vogue in the browser in a couple years, it's going to make CSRF almost go away for us without even ever having to think about it. Just use the web. And when it comes to these new bleeding edge defenses, Chrome picks it up instantly. Firefox is soon to follow. But we always have two browsers that are laggards when it comes to some of these bleeding edge security standards, is IE and Safari. And Safari is probably the worst of them all. IE is trying to play ball. And so, what we can do as a community is help inform the different browser developers that we do want these defenses in. And I think they're very receptive to these conversations, right? Let's talk about SQL injection defense. Again, how do you what is the conventional wisdom of how we tell developers not to do SQL injection? What's the conventional best practice wisdom today? And? No, it's parameterized queries and the binding of variables. Because you can use the MySQL PDO library, the Java prepared statement class, the active record API, and just build a query dynamically and shove it into the prepared statement call, and you're vulnerable. So you have to, I'm picking hairs. You got the right answer, guys. You got to parameterize and bind all your variables. But that requires the programmer to conduct a certain activity. What's the first technology that came out that auto-protected us from SQL injection just by using the technology? You don't have to write code a fancy way. You just use this abstracted layer, and SQL injection's impossible for your code. No, and that's part of the answer. That's part, not nope. Yes, it's not complete though. What technology and what framework just automatically gets SQL injection protection? Because if I'm using an ORM in Java, I'm talking it to 8-byte HQL, Hibernate query language or object query language, and I don't use parameterization, I can get object query language injection or Hibernate query language injection. ORM's a piece of it, but it's not the full answer. Which technology and which framework was the first to give us 100% SQL injection protection? Stored procedures do not, several books say this and they're all wrong. You can write a stored procedure that's callable in an injectable way, and that's injectable in the code itself if you don't parameterize properly or build the stored procedure properly. Anyone who tells you stored procedure gives you automatic SQL injection protection is flat out wrong, and many big books from big publishers say this, and they're all wrong. Makes it difficult to, get this knowledge out in the right way. No offense meant. .NETers, what technology did you have in 2007 that stopped SQL injection cold while most Java and PHP apps are getting ripped apart? Almost. The link system, the language integrated query system, and it's an ORM. It's an object relational mapping engine. First of all, you can map .NET classes to specific database entries, and then you just write the query, throw variables into it, and it will automatically parameterize the query when writing SQL. This is brilliant because now as a developer, I just use this technology stack, slap my queries together haphazardly, and I'm at least immune to SQL injection. And this is just fantastic. What's wrong with this though? Where does the developer have to do a lot of labor to pull this off though? the actual object relational mapping part of it. Anybody here ever work with an object relational mapping engine before in their career? How much time did you spend writing code, and how much time did you spend tweaking configuration and testing? Tweaking configuration and testing. Does that sound familiar? You spend all your time living in an XML file or a JSON file fixing your mapping, and you just want to beat your head against the wall after a few days of doing that. So it's a lot of work to do object relational mapping. So how can we write a SQL statement that's closer to SQL? Well, now we have Ruby on Rails 2011 who took a stab at it with Arrow. And Arrow gives me a meta query language that's one-to-one mapping with SQL. It looks like SQL, but I'm defining but it's not exactly SQL. It's giving me a meta language abstracted above it that is pretty much one-to-one with building SQL that auto-parameterizes everything. That's a step in a better direction. It still stops me from writing SQL, though. It still forces me to use an abstraction, which is a hit. So here's where I think the future is. This is a proposal from one of the Google employees that came out just a few months ago, and it's under heavy discussion for Java 7, for PHP 7.1 or probably PHP 8. What he's doing is basically taint tracking, and not as a plugin or as an add-on, but as part of the PHP core language itself. And he finished this, and it's pushed live, not in PHP, in his demo site. You can look at it here. He could detect if a variable is static. And if it's static, could be a lot of different things. We'll look at that in a second. If it's static and all the elements of your SQL come from static sources, it's a safe string. If any part of the SQL is dynamic, then it's dangerous and it will block the query from running. And this is something you can push live into an existing PHP application with zero developer activity and protect you from SQL injection. So these are static, right? This is select star from table, or we're defining a static call, and they know, even though this is string concatenation to build a query, we know it's just we know it's a static portion of a query, or even this is determined to be safe. Even though the user type is dynamic from the user, we're only going to put the static admin or user in this variable. So injection's not possible with this code, and this proposal will recognize that. This is also safe, pulling data from config. And this is how you circumvent it. Security, disable SQL injection protection. I like it because it's very clear that you're doing something that's crazy, but we have to do this. If I'm building an administrator screen to run SQL, then I need for those kind of tools, I need SQL injection by design for admins. And this is an unsafe query, where now a variable is directly dumped into a query. It will just explicitly block this. It's automatic defense, no developer activity needed. During runtime, the developer's query will stop running. They'll get an error message saying, you just put an open variable into a query. We're not going to let that run for your own sake. Please go fix it. And look, this is a major change to PHP. It's the right thing to do. There's a lot of the core developers of PHP core who do not want this to roll in. It's a heated debate. So those of us in the AppSec community, if you care about PHP, I care about PHP, jump into this conversation and add your feedback to this proposal. I think PHP team core realizes they need to add automatic SQL injection and cross-site scripting protection at the language level, and they're really just at the forefront of that conversation, taking it seriously. So if any of you depend upon PHP, care about PHP, or like to issue snarky, anti-establishment comments about PHP, go make it better. And this is the conversation where it's happening right now. We also have a few things to make HTTPS easier. I used to trash mobile application wrappers, and but these are brilliant. I was in a situation recently where this developer and this team, low resourced, they needed to move the whole app to be HTTPS. It's not easy to do HTTPS on the client. You have to manage that connection yourself in code. So there's a few companies that will give you a wrapper for your mobile app. You wrap it, and now only thing leaving that little mobile app is well-tuned HTTPS. And I'm kind of changing my tune because it's a quick win. It's not that expensive. You hit the right vendor, and it provides pretty significant security out of the box. One other quick note before we finish up is HSTS is not playing well with mixed content. If you have mixed content, it can actually block your page because the mixed content check happens before the strict transport security check. So one of the new things we see in CSP, which was recommended like 4 days ago, I'm trying to show you new things, a 4-day ago conversation, it's the upgrade insecure request call. So now, when I hit your first page over HTTP, and you respond with a content security policy, and you know the whole site should be HTTPS, you can tell the browser, upgrade insecure requests, so everything else that that domain does within that policy time is going to only make HTTPS requests, even external links. And strict transport security does not do that today. Strict transport security blocks. And this is saying, let's force upgrade. Here's the problem. If you're the New York Times, you have an infinite X number of articles out there. And your archives are now all HTTP from many years ago. Do you want to go back to your 50,000 articles and change every HTTP link to HTTPS? The answer is no, you don't. That's a monstrous problem when you're a publisher with that problem. So we have this proposal, from Mike West, to allow like the New York Times to deliver this CSP policy, and without rewriting 50,000 pages or more, force the whole site to use HTTPS at the client level. Go ahead, sir.
Could you just do URL rewrite at the server level? Say if it comes HTTPS?
Famous last words. When you have like several 100,000 pages, good luck with that. This is just another way to go about that. It's less. Why is this so important? It's less effort for the developer. They just do it, and the whole site changes. It's going to take years before this really sinks in, but it just makes it easier on the developer, and it's automatic. Writing those rules can be super problematic. And do I have another minute, or no, I don't? Okay. And now to you. Normally, when we want to do HTML validation, we build some kind of XML or programmatic policy to determine which tags are okay and which tags are not. And when you have a complex policy, this becomes difficult to manage. This is best practice right now. It's the OWASP Java HTML sanitizer. This is what I use in production. But we can go about this in a different way. This is where language security comes in, where the idea is to treat data like code, to auto-tokenize everything, run it through a VM simulating the browser. This is the kind of things more of the advanced thinkers in this area are doing. And they can get wire speeds with and very low false positives with this kind of thinking. And it's interesting from Kunal Anand. He talked about this yesterday. It really made me look differently at how I do HTML sanitization. Now there's automatic methods both on the server with these kinds of defensive techniques as well as on the client. Here's a discussion from a few days ago. David Ross, also from Google, wants to build a safe node. Instead of having me do a whole policy on which tags are good, which ones are not, that's a rat race you'll never win. Now we can take a node and say, let's enable the safe attribute and don't allow external content downloads. There's many other rules we can add. Now I have this untrusted markup from a WYSIWYG editor, and I could just drop it in the safe node that has this rule, and it will automatically do the sanitization for me. Again, the things I'm trying to highlight in this talk are things that are automatic, that we can take the developer out of the equation to some degree. And we have Spring in 2013 adding a variety of these security headers by default. Ruby on Rails in 2013 added X-frame option. And these are just every single response just by using this framework adds all these security headers for us, and the developer has to turn it off. It's not off by default, turn it on. It is on and enabled by default, and they can modify it if necessary. This is the hope for a better future. And by the way, identity and access control, here's the answer to that. It's just hard freaking work. Sorry, guys. There's no way around it. These are two areas you want to invest heavily in early on in the life cycle, because you have to rewrite your access control layer. You're rewriting the nervous system of the whole app. So I'm almost over time. The point of this talk is that do not lament. This is a great time for security folks. We're getting paid well. We're getting, that's a blessing in a difficult economy. We're being listened to for the first time in security history. We have huge amount of intellect going into building a more secure future. Don't worry about the problem. Worry about the solution and try to help move that ball down the field. I hope this conversation helps push you in that direction in some way. Thank you so much for being here. Any questions before we wrap it up? Let's do it in the mic, sir, if you don't mind.
You talked a little bit about Angular, but is there any other frameworks that really stand out to you that are just doing it right and they're
Go.
nailing everything?
Go is very close. Go has the best contextual escaping of any template system. It's doing double encoding in some contexts. I barely even talk about that in teaching, but it's the right way to do it, and it's automatic for them. That's genius. That's Mike Samuel, other people's work who pulled that off. Why I like Angular a little bit better, though, is it does escaping, CSP, and HTML sanitization all built in. I know of no other framework that is that complete. So if you're going to build these other components in the future, follow their lead. That's what I need as a developer to really stop XSS. It's not tough. Any other questions? What a great pleasure to have you all here. Any questions? I'm jim@owasp.org. Go forth and write and help people write secure code. Enjoy the rest of the conference. Thank you so much, everyone.